Hello, in this tutorial a group of meshes will be converted to a new mesh which will be used to make a relief sculpture using CNC machining or 3D printing. You can assemble a group of meshes in your favorite 3D modeling program, or you could assemble the meshes in AccuTrans. The model I'm using here has 13 layers, and if I rotate around we can see we've got a full head with our wall going through it, which is textured. The colors and the UV texture on the mesh isn't necessary because it won't take any part in this process. And you can see the model doesn't look very smooth because we're looking at flat rendering, and this is what is going to be translated into our final model. If you have some smoothing put on, such as vertex normals, which I'll calculate here, you can see the model's face now looks much smoother, but that won't transfer through to the sculpture relief. Now we have two things with this model which would cause problems. One is our semi-transparent eyelashes, which will look terrible when converted. We don't want that to take part in our conversion, so I'll just turn that layer off. And now if you look at this area here, as I rotate the model, you can see it moves around and it changes, and we're seeing the textured plane behind. This is a hole which should be filled up before we do the conversion, but I'll just leave it this way so that you can see what happens. And now I'll just reset the camera, and the model can be made of both textures and triangles, which these two edit boxes show us here. It could be all triangles, or it could be all quads. And now the digital probe will take measurements along the ground plane. In AccuTrans, that is the X and Y axis. And if I take and click the top view and we look down on the top, we can see that we would produce a new mesh of the top of the head, which isn't what we want. So what we have to do is rotate the model into the right orientation. So I'll click on the Adjust Object button, and that puts in a new group of controls here. We have the location of where the model is in the world, and it can be any place in the world. And now we want to rotate it. So we can either rotate around the midpoint or rotate around the origin. For what we're doing now, it doesn't matter which of these two I would use, and I want to do a -90 rotation on the x-axis. So I'll do that, and now as we're still in the top view, now we can see the what the digital probe is going to see. And if I click on the front view back down, you can see now the orientation looks different than we saw before. The nose of the model is pointing up, so we're going to get the right view. And so I'll click OK here, and now at this point, any adjustments you've made to the model, you might want to save it to another file in case something goes wrong later on and you want to revert back to this stage of the process. But what I'm going to do is I'm going to go to the clipboard, copy layers to the clipboard, and then select another work area, and I'm going to do clipboard, paste layers from clipboard, and now I have my model plus the original one. And the eyelash layer is now gone because since it was turned off, it didn't get copied over. So now to activate the digital probe, I go to the Tools to Convert Mesh to Landscape Terrain. And to create the digital probe works as though you were putting a wire pushing a wire screen down onto the model, and where the wires and the screen touch together is where a vertex will be created. And the closer together you put the vertices, the more detail you will get from the original model. Plus, you will get more triangles in the final model. So for this model, I'm going to use a grid spacing of 0.005, and I calculate to see how many vertices I've got, and there's going to be 44,197, which is going to result in 87,552 triangles. I don't want to drop any lowest faces, I don't want to add a base, and I don't want to add UV coordinates. I could also convert to a landscape as another option. And so what I'm going to do is click OK, and we now have our model. And if I rotate it around, you'll see that down here you can see from that hole that was there, the digital probe went, and it went down till it hit the plane, and that's what it made the bottom of the thing. So you want to close any holes in your mesh before you do this part of the terrain. Now that we have our mesh, we can go back to Adjust Object, and now we want to scale and position the model to go for the CNC machining. So now we want the bottom left corner of the mesh to be at the origin. So I'll click this button, Set Minimum at 000, and that's where our position is there now. And so now this is the size we have of the model. But we'll say, okay, I want the model to be 2 feet and 3 inches tall, which is 2.25 units. Now, AccuTrans has a unitless system of measurement, which means a unit can be anything you want it to be. So what I'm going to do here is I'm going to click Calculate Scale. I'm going to select the y-axis because this is the height. I want this height to be 2.25 meters. So I'll put my new size 2.25 feet. So I put 2.25 feet in there, hit Calculate. I have the scale factor, click OK. The values are entered here. I click Scale, and my model now measures 2.25 feet on the y-axis. But now the company where I'm going to have do the CNC machining, their software is expecting to see the dimensions in millimeters, and I'm in feet now. So I've got to rescale the model again, so I'll click on Units. I go here to Import Units. I select feet because that's what the model is in now. It's set to meters, but I don't want meters, I want millimeters. And that gives me another scale factor to go from feet to millimeters. I could put in a second scale factor if I wanted, but I'll leave it at 1, and I'll click OK, and that number gets entered here. I click Scale, and now I've got the size of my model in millimeters. And so now for CNC machining, the software used there to cut the tool path usually accepts both DXF and stereolithography files. So I'm going to click on the option button, which brings up the Save with Options dialog box. And so I've got my choices of what I want. I'm going to do DXF first. And so now we're set to export to DXF files. The settings in this flags group applies to every file format. If we go to the output scale factor page, we want the scale factor set at 1 because we've already scaled the model to the right size. And for some file formats, such as DXF, there's a second page. and we want to be output as 3D face and output tables, blocks, and entities. So now all I have to do is go click Save. The standard Windows Save As dialog box opens. Select the folder where you want to save, edit the name to what you want, and click the Save button, and our DXF file is now saved. Now, if I needed stereolithography, I could go down and I could select stereolithography ASCII, and there is no extra page here because there are no extra settings when saving to an STL file, and then I could just click Save and save to the file. Now, we also have another choice, is binary, and binary gives a smaller file size, but you might find out that some people don't accept binary, but probably most of them do. Click Save and change the name to what you want after selecting the folder. Click Save, and there we have both our files are saved. And now if I just collect another work area down here, and I'll bring up AccuTrans accepts drag and drop for a lot of file formats. So I just saved the DXF and STL files to my Relief to CNC folder. So all I have to do is drag over the DXF file, and there is the DXF file that we saved. I could close that out, bring the back, and this time I'll drag over the STL file, and there's our STL file. Now I'm going to go back and and do another paste from clipboard. My values, there's my object that I had before. This time I'm going to go back to Tools, Convert Mesh to Landscape and Terrain. We've got all our same units, so I'll say Calculate, but this time I'm going to go Convert to Landscape and go to click OK, and now here's our object as a terrain. And now I can go to convert that terrain. I could save directly out to a DXF or STL file, but instead I'm going to go to export to 3D and keep it in AccuTrans. You can skip vertices and go to here I'm skipping 8 vertices, only going to that many triangles, but you'll get a much coarser looking model. And I'll click I'm going to keep all the faces, and I'm going to click OK, and here's our model. A UV coordinates were applied to the model, and this is a default texture that is applied by AccuTrans, and I could take and I could remove that by going here. It's still UV coordinate, but you're not seeing that funny looking texture. So there's our landscape, there's our model. Looks quite a bit like the other one. Sometimes, depending on the settings you make and so forth, when you go through the landscape terrain, you could end up, your model could come out and it could look like it was made out of a whole series of layers which show distinct steps like a set of stairs for the model. But this one come out okay. Now, if I wanted to take and go to 3D printing, I could just click on this model. I'm now in the 3D printing module. I put a thickness on. I can either do a normal extrusion or a flat bottom one. I'm going to do a normal one. Click Extrude. Okay, it's extruded. I come through, and there you can see what happens there with the normal extrusion. Click OK, and if I do a watertight check, it's all watertight. It's ready to go. Now that's one way of getting there. Now I could also, going back to the we'll paste from a layer, go back to the convert mesh to landscape, do the calculate, OK, here we're back in. Now, if you wanted to do some eroding of the cliffs, you could go to this control here, which is smooth cliffs, and I'm going to click it twice, and then convert to 3D. And now we can go down. If we looked at the ear, you can see it's changed shape in there, and it's not as it's smoothed out more than our original model, which was this one. And if we can come over here, you can see the ears are more stepped looking. So that's another option you have. And there's one more option we have. We can go to, again, paste our model back from the clipboard, go to convert mesh, and this time I'll do the calculate. I'll go to convert mesh here. I'll add a base on it. I'm going to leave it at the 1 thickness. I could put UV coordinates on if I wanted, and then I'll click OK. It's calculated, and now we've got a big block with our face on it. And if I do a watertight check, there it is. It's all ready for 3D printing. Well, we would have to go and scale the model to the right size. And we'll just go back there. And there's one thing. Sometimes when you've got the model up, I'll pick the front view, it's oriented like this. Because there are 3 different coordinate systems in popular use, when you take the STL file or the DXF file in, you might find that the model isn't oriented this way in the front view. So to fix that up, what you would do is go, before you export, is select rotate about origin, and then do either a -90 or a +90 rotation around the x-axis. And you'll just have to run a test to find out what you need. And if I did say a +90, it comes like this, and then I'd go ahead and export it to the STL file, and then it would come in and would look oriented like so. So that completes this tutorial. Goodbye.